example 2.2. Okay, for what value of m the vectors a and b are perpendicular to each other? So this is the thing. So question 1, if a vector is equal to a m I vector 2j vector and k vector, and b vector is going to be 4i vector 9j vector 2k vector. First case 1, given a vector is perpendicular to b vector. So it has been given that a vector and b vector are perpendicular to each other. So when they are perpendicular to each other, the dot product is equal to 0, right? We know when two vectors are perpendicular to each other, the angle between them is 90 degrees. Therefore, a dot b vector, the dot product is going to be 0. Hence, this is the a vector given, this is the b vector given. Let us do the dot product. We know how to do the dot product. When you do the dot product, the components similar to the vectors are only taken. Okay, the rest gets 0. M into 4 is 4m minus 18 plus 2 equal to 0. Resolving that, we get m equal to 4. Second question, same case. Here it is going to be a vector is this and b vector is this, and it is perpendicular, right? So the dot product we found once again, 5 into m, 9 into 2 and 2 into k. Remember the property we had said before. This yields the result m is equal to 16 by 5. So we found the 2m values. Let's solve this example 2.3. A and b vectors are two vectors, such that the modulus is 4, modulus of b vector is 3, and a dot b vector is 6. You need to find the angle between a and b vector. Okay, you remember that there are two things. So we got the a vector like this, and there is going to be a b vector somewhere like this. Okay, we need to find the angle between them. We know this is a vector and this is b vector. Okay, so we know the value of this is, modulus of this is 4 and this is 3, and a dot b is like projection, right? So we should remember the projection formula. So a dot b is 6. What is a dot b? This is a dot b and it's 6. A vector dot b vector, right? So find the angle between them. We need to find the angle. We know the cos theta rule. A dot b cos theta equal to a vector dot b vector. That a dot b, this is from the rule, a vector dot b vector is equal to a vector dot b vector. Hope you remember, we solved before, right? Cos theta. So taking these guys here makes cos theta equal to this. Okay, substituting the values from here, get 6 by 4 into 3, that is equal to 1 by 2. So theta is equal to what? 5 by 3, that is 60 degrees. Cos 60 is 1 by 2, right? So pi by 3 is 60 degrees. We take the next example 2.4. We need to find the angle between the vectors. Let us give a label, as a vector is this guy and the second vector is the b vector. That is this is a b vector and this is a vector. We need to find an angle between them. What it means? Assume this is a vector. So we need to draw two vectors, right? One is this way and another is somewhere in the three-dimensional thing. So in this x, y, z three-dimensional space, we got a component. You see how this is with respect to the x, y, z plane. Same way we got the b component, right, with respect to the x, y, z plane. So we need to find the angle between these two vectors. So we just gave a name, right? So we know what is a dot b vector. When we need the theta, always remember we have to bring it to the projection formula. So we have to take a square somewhere. So what is a dot b? It's 12. We have to multiply these two, right? So how do we multiply these two? The components, the relevant components need to be multiplied. So it's 34. We know the modulus of a vector is 7. Modulus of b vector is 9. So these two are given. How to find the modulus of a vector? It's square root of 3 square plus minus 2 square, right, plus minus 6 the whole square. So same way, square root of 4 square minus 1 to the power whole square plus we have to sum up all this kind, right? 8 whole square. This is how we get a and b vectors. Okay, this is how we got these values. Finally, we need to find the cos theta. Okay, that we know the cos theta formula is a vector b vector dot b vector modulus of a vector multiplied by modulus of b vector. Substituting these values we got, right? So we found theta is equal to cos inverse of the minus 34 by 63. Okay, this is how we find the value. Same way, the example 2.5, we need to find the angle between a vector and b vector, where a vector is I minus j, b vector j minus k. So we have to assume plus 0k. Okay, plus here what? 0I. Okay, that's all. So now, remembering this, let us solve it. Okay, how do we solve the angle between formula is cos theta? This we know very well, right? So cos theta plus this thing. So a vector dot b vector is what? So we have to do the dot product of this one. So I into 0I, I into I is minus 1 into j. This is how we have to write. We have to remember here is 0k and the k is 0, but here is I is 0. Okay, this is what we have to remember. So this value comes like this, minus this into 0 is 0 and this into minus 1 into 1 is here, and the same way 0 into here is 0, 0 into minus 1 is going to be 1. That's all. Then square root of a vector, modulus of a vector, modulus of b vector. How to do the square? You have to take square root of what? 1 square minus 1 the whole square. We have to add like this, both the cases, right? So this is what we got, square root of 2, square root of 2. Hence, when you add up, we get cos theta equal to minus 1 by 2. What is the value of theta that gives that? Is we have to find that one. That is going to be 2 pi by 3. Okay, from the table we find theta equal to 2 pi by 3.